Welcome students. Let us continue the part 2 of this physics lecture series on moving charges. The magnetic induction due to infinitely long straight conductor. Let us consider X, Y as an infinitely long straight conductor carrying the current I. Then where let us consider the smallest element, shortest element, smallest infinitesimally very small element, that is dl, that is AB of length dl. Now the distance between the center the AB, that is the dl, and the point P under observation, is it not, that is influenced by the magnetic field created by this length element, current carrying conductor in the length element. So that is the distance between them is R, that this center of the AB and P is R. Then now let us consider this is the AC. Do you understand? This is A, this is B, and this is C, a perpendicular C. This is C. Okay, C. AC, right? Then that makes an angle D phi. Do you understand? That makes an angle D phi. D phi. Now, and the distance between O and P, the distance between O and P, okay, distance between O and P, this one, and we have another angle, that is phi, that is OPA is phi. What is that? OPA. Are you able to see the right angle? So OPA, that is phi. This one is phi. Phi. So, and now let us proceed. Then, as and when required, we will explain the label. According to the Biot-Savart's law, dB, that is the magnetic field created by the current carrying conductor in the smallest portion dl, is equal to mu naught divided by 4 pi into ideal sine theta divided by r squared. So what is mu naught? That is permeability through free space. I, current strength. dl, the smallest length element, that is AB, which is nothing but dl. Sine theta, you know, and then divided by r squared, the distance between the point P and the center of the length element AB. AC is drawn perpendicular to BP. So we have drawn AC, which is perpendicular to what? The DP. Okay. So here that is equal to, that is BP from A. OPA, that is phi, that we already explained here. OPA is equal to phi. Similarly, APB, the smallest angle I was explaining here, that is equal to D phi. Are you able to identify APB? Where is APB? APB, that is this one. So this is D phi. Do you understand? D phi. Then in triangle ABC, where is this triangle ABC? You have A, B, C, right? So ABC, let us draw this as ABC, ABC. That is, this is AB, this is AB, and this one is C. This is C, this is B, this is A. You know very well this is right angle. Okay, now this is theta. Okay, this is theta. Then And if it is theta, this is right angle, then AB, that is the length element, which is nothing but a hypotenuse, is it not? You can call it hypotenuse because the side opposite to the right angle is hypotenuse. Follow me carefully. Now, what is sine theta from this triangle? Sine theta is equal to, which is opposite side to this, that is AC. So AC divided by AB, that is hypotenuse AB. So that's what given here. Okay. Now what is AC? AC is nothing but what? That is the distance between this one and the, okay. Now divided by DL. DL is AB. That is AB is the shortest length element is AB. That is DL. AC by DL. Therefore, sine theta is equal to AC by AB, which is nothing but AC by DL. Therefore, AC is equal to, we are interested in AC, that is equal to DL sine theta. So, you can keep this equation. Right. Next, from triangle APC. So, the same thing, triangle APC. Let us consider triangle APC. Where is it? APC. Is it not? So, triangle APC, this angle. APC, which is having D5. Is it not? D5 as angle at P. So, in triangle APC, you have D5 and the AC is the arc of the length. We know that is arc of the length is nothing but R into D5. So AC is equal to D5 and this AC is nothing but DL sine theta. So you can equate this R D5 is equal to what? DL sine theta. Right. Now dB is equal to mu naught divided by 4 pi into I r into d5 divided by r squared. Why? Because we have substituted dl sine theta by this r d5. So r d5. Do you understand? And therefore divided by r squared. Now mu 0 by 4 pi into r can be cancelled. Now you have I d theta divided by r. Do you understand? Right. Now let us proceed. What is the OPA? OPA. O, then A, and then P. So OPA. So here we have we can have this one OPA. We have drawn this diagram here. What is cos phi? Cos phi means phi is here. Cos phi. So right angle is here. Opposite to that is hypotenuse, and this is A. OP is A. It's marked as A. So cos phi is equal to, what is that? Adjacent by hypotenuse. Therefore A by R. Is it not? So cos phi is equal to A by R. So that's what we have given here. You understand? Cos phi is equal to A by R. From this R is equal to A by cos phi. Then we can put dB is equal to mu naught divided by 4 pi into I by A. Then cos phi into d phi. Why? Because we have put here I d phi divided by R. Instead of R, I have introduced by A cos phi. So A into cos phi, because reciprocated, cos phi d phi. Now on integration, because it is only a differential element, so we need to find the fullness, the full magnetic field. So integrate between the limits minus phi 1 to phi 2 means that is we have to extend it. This is minus phi and that is plus phi. So minus phi to plus phi, so that we can find out the complete stretch of the infinitely long conductor. Therefore minus phi 1 to plus phi 2, that is integration between the limits of d phi minus phi 1 to plus phi 2 dB, that is equal to again minus phi 2 phi 1 to phi 2, that is equal to mu naught I whole divided by 4 pi A. 4 pi A. So being constant we are isolated and I have taken only cos phi d phi. So cos phi d phi. Right? So cos phi d phi. So therefore we know on integration it becomes sin phi. and between the limits of phi 2 and phi 1, is it not? Initial is minus phi 1, final minus phi 2. So what we need to do? Sine phi 2 minus of minus sine phi 2, is it not? Phi 1. Therefore it becomes plus. So you can put simply sine 1 plus sine 2, that is the integrated value. So b is equal to, because we already know, please remember, integral of cos theta is equal to sine theta. So based on that, now we have to integrate between the limits. So this is done between phi, what is that? Minus phi 1, phi 2. So this is minus phi 1 and this is phi 2. So now we have to substitute this phi 2 and phi 1. Therefore, I have changed it into phi 2 and phi 1. Do you understand? Now, so minus of minus, it has become plus. Now B is equal to mu phi, mu naught I divided by 4 pi epsilon into sine phi 1 plus sine phi 2. Now phi 1, see, being a long conductor, so this is the value, this is phi 2, this is minus phi 1. So it is a complementary, is it not? So phi 1 plus phi 2 is equal to 90 degree, so 180 degree, and therefore it should be equal to what? 90 degree equal. So phi 1 is equal to phi 2, that is equal to 90 degree, right? Then now you can bring sine 90 plus sine 90. So sine 0, 0, sine 91. So 1 plus 1, how much? 2. So 2 is cancelled here. This is 1. Sine 90, sine 90, that is equal to 1. And this is also sine 90, that is equal to 1. So 1 plus 1, 2. Now you have mu naught I into 2 divided by 2 pi a. So 4 pi a. So you can strike out, so you can put 2 here. So 2 pi a. So mu I divided by 2 pi a. So B is equal to mu I divided by 2 pi a. Just believe me, you can find out, you can determine the magnetic field. You know the value mu already being a constant. Only thing is you need the I. I is current strength. And what is this A? The distance between the what? That point and the center of the conductor. Is it not? So I A. Do you understand? So far we have discussed between the, the magnetic field along the infinitely long uh, conductor, straight conductor. Now let us apply the same logic, but for the circular loop. So magnetic induction along the axis of a circular coil. So if it is a long stretch, a straight conductor, it will be like this. Now you are going to have a circular coil like this. So in the case of circular coil, just understand the arrow mark. Okay. So this is circular coil. AB is the length element of the coil. AB is the length element. So this is the smallest portion. AB is the length element of the coil and it is DL. C, the center of a length element. The center of a length element, that is, this is a length element, its center is C. So this one, center part, C. So C is the center of the length element. O is the center of the circular coil. O is the center of the circular coil. Now CP is the R. So the distance between the center of the element and the P, that is regularly taken as R. So the distance R. And then now we have, let us apply the Biot-Savart's law. Okay. Now listen here. And the distance between O, the center of the circular coil, and the point P, that is X. According to Biot-Savart's law, dB is equal to mu 0 divided by 4 pi into IDL sin theta divided by R squared. What is I? Current strength in ampere. That is passing, the current is passed through the circular loop. DL, the smallest length element. Sin theta, the angle. then r, the distance between the length of the, I mean the center of the element, and p. Then according to Biot-Savart's law, this is the equation. Theta is the angle between the ideal and r. So ideal and r. So this is the theta. Then now if here theta is equal to 90 degrees, so this theta is equal to 90 degree in this case. This is the angle and this is 90 degree. Why? Do you understand this? This is the curvature like this. From this I am making a right angle, so this is right angle. Okay. Then theta is equal to 90 degree, and then dB is equal to, now we can apply this, mu 0 divided by 4 pi into ideal, and sine 90 is equal to 1. So sine 90. Do you understand why it is sine 90? Because this is the circular element and this is perpendicular, this portion. So let me consider AB and this is P. So this part is perpendicular. Okay. Now this part means that is, it will be like this. This is the axis. So this part. So perpendicular 90. Therefore sine 90 is equal to 1. Now that is eliminated. So ideal divided by r squared. So 4 pi divided by r squared. Then the direction dB is perpendicular, as I already mentioned, perpendicular to the current element IDL and CP, C and P. Now it is therefore along the center, the PR, perpendicular to the CP. Do you understand this? PR, where is PR here? This is PR. So this is PR and this is also perpendicular to this. Now, and what about the dB element? This is dB cos alpha and this is dB cos alpha. This is also dB cos alpha. Now this is alpha. This is the resultant vector. So when it is resolved into vertical and horizontal component, it becomes, that is dB sin alpha. And what about this? dB cos alpha. And its opposite is dB cos alpha. This is. Then you have that is m, dB cos alpha, Pm. That angle is alpha. Then now alpha is the angle between, you just go through that. What is that? The alpha is the angle between the axis of the coil. Where is the axis of the coil? This is the axis of the coil. This is the axis of the coil and the axis length is x. Right? Now, so angle between the axis of the coil and the line joining the element and P, that is R. Is it not? The line joining the element, this is the element, and P, so which is nothing but R. So the angle between X and R is alpha. Then B is equal to, now integral dB sin alpha, that is equal to mu 0 4 pi into ideal r squared into A by R. Then we know that is a mu 0 by 4 pi according to the what about this mu 0 4 pi and then I. So these are all constant. A all can be brought outside the integral and the differential element length alone is the integratable. So that can be integrated. So integral dl, other things are kept outside the integral. So when you integral over the cycle, which is nothing but what? That is the circumference of that circular loop, 2 pi r. In this case, 2 pi a. What is a? A is the radius of the circular loop. So 2 pi a. Do you understand? And therefore, mu naught ia squared, because a squared 2 pi cancel. Now you can put 2 r cube. So this r is nothing but, according to Pythagoras theorem, a squared plus x squared. Is it not? You please go through that. What is r? R is the hypotenuse. Is it not? X is the hypotenuse because this is 90 degree. So x is hypotenuse. So x squared is equal to a squared plus r squared. Okay. Now, I'm sorry, this is a right angle. This is a right angle AXR. Therefore, A squared plus X squared is equal to R squared, right? So A squared plus X squared is equal to R squared. So this R can be substituted by this equation. Therefore, we have taken, that is A squared plus X squared. So if it is R squared, means R is equal to A squared plus X squared whole power 1 by 2. Now this is R cube. So cubing on both sides. So it becomes what? 3 by 2 by applying a power m whole power n is equal to a power mn. Therefore 3 by 2. So you have 3 by 2. So what is the final equation? Let me write here. That is B is equal to mu naught I a squared divided by 2 into a squared plus x squared whole power 3 by 2. Do you understand this? I just replaced this. Then if the coil contains n number of turns, that has to be multiplied by n. So you can simply put n. So mu 0 into n into ia square. So let us put n in this case, n. And then at the center of the coil, x is equal to 0. So we are studying various cases. Suppose what happens when the point is P is at the center of the coil, that is nothing but the x becomes a 0, is it not? So this is the P at a distance x. When the P is brought on O, it means x is equal to 0. So that's what it is given, x is equal to 0. Then in that case, it becomes a squared whole power 3 by 2. Squared can be cancelled. So a cube and a squared in a cube, then a squared. Therefore 1 by a. Do you understand this? That is B is equal to mu naught n I a squared divided by 2, what is that, a squared, and then because x is equal to 0 whole power 3 by 2, means that is equal to mu naught n I a squared divided by 2 a cube, because these two can be cancelled, a cube, and again you can cancel, so divided by a. So therefore B is equal to mu naught n I divided by 2a. So this is for the circular coil, that is current passing through the circular coil. You understand? So based on that, we will move to the tangent galvanometer in the next session.